Hello, my name is Adib Saikali. I'd like to show you how to install Tanzu application platform on Docker desktop using the built-in Kubernetes. This can be a great solution for a single person who has a powerful machine and would like to avoid the cost of and the maintenance of running a real multi-node Kubernetes cluster on a cloud provider or somewhere on-prem. Let's get going. So what we'll start with is the Git repository that I've created called local tap, which is on my GitHub page. In this repository, you're going to find a set of shell scripts. You'll notice that they're numbered starting with 0001 all the way to 7. And then we have a group of 20, 21, 22, 23. These are our debug scripts. And we have a script number 30, which is our delete script. There's also instructions in here. And so let's just get going, and I'm going to show you how to use this repo. So what I'm going to do is I'm going to start by just seeing what's in my Kubernetes cluster. As you can see, my Kubernetes cluster is currently empty. When you're using this repo, you start over in the configuration folder. The configuration folder contains a settings template.sh file. This file contains a set of environment variables that drive the installation. These environment variables, you're supposed to take it, the settings template.sh, you copy it over into a file called settings.sh, and that's what where you will put your particular settings. Now, the first thing we need in order to install Tanzu application platform is a domain name. Now, because we are installing it on our desktop computer, we can use IP address 127.0.0.1 in order to do that. So what I've done is I've prepared a wildcard domain on the subdomain on tanzu.ca. So if I go here to my terminal and I do something like ns lookup tap.local.tanzu.ca, you'll notice that the response comes back as 127.0.0.1. In fact, I can really ask any answer here. I can just say deep.local. It's always going to come back as 127.0.0.1. This is really great because it means when we deploy workloads to tap, they get subdomains, and this scheme will continue to work. So the next thing you need is a username and password for the Tanzu container registry, also known as TanzuNet. This is available for you online. So if we go here to network.pivotal.io, this is my old name that I remember from Pivnet. And you can see here we're on the VMware Tanzu network. You can sign in. You can also create an account and all this type of stuff. So I'm not going to show you how to do that. I just assume you already have that. So what you'll do here is you'll put your username and password. This is clearly why I don't show you mine. The next thing you're going to need is we're going to need a container registry where we can publish our containerized workloads. And so this is a container registry where you have both read and write access. The TanzuNet registry, we can pull the tap container images from it, but we can't publish our workload images there. So once you have a registry created, you can put the registry host name there, the username and the password, and we'll assume that there's a project within that called tap. Now, different container registries behave differently. A good choice you can use here would be maybe something like GitHub, Harbor, ACR from Azure, or maybe you can use the Google Artifact Registry. It doesn't really matter. You just need a container registry that you can use. The last thing you need is a client ID and client secret from GitHub. What we're going to do is we're going to configure our tap installation to use GitHub for authentication. And so what you need to do is you need to go to GitHub, you click on your name, you go down to settings, and then under settings, you're going to find a section called developer settings, and then you're going to find a section called OAuth apps. And in this OAuth apps section, you can register a a local tap. When you register it, you're going to get a client ID, you're going to get a client secret, and most importantly, down here, you're going to specify the name of the application. You can use whatever name you want. And for the URL, it's important to put https://tap-gui dot, and then this portion here is whatever your domain is. Now, you can, because it's pointing to 127.0.0.1, you can actually use this exact value in your installation. And the authorization callback is the same. Once you save it, you can generate a key, client ID, and a client secret, and you can copy the client ID and put them in over here in the client ID and client secret. The last section here is you don't really need to change it if you want to use the version that these scripts are using. This is all based on Tanzu Tab Application Platform version 1.7.2. So I have here, I've already in the configuration settings, there's a copy of the bundle lock file that points at the kind of the cluster essentials that we need for getting going. What you'll find in here too are a couple of other things like the template, tab values, template YAML. You don't have to edit this file because all of the values that you're putting in your settings, they kind of get injected into this file. So let's go through step by step. We're going to assume that you've created your settings.sh and you've configured it correctly. The first thing that we need to do is to start running these scripts. I'm going to start with script.00. This is going to check that a bunch of CLIs are installed on your machine. The scripts are going to make use of image package, YTT, kbuild, cap, kubectl, JQ, and a networking utility called SOCAT. These are all open source utilities that you can just install on your machine using brew or other means. The next thing we're going to do is we're going to check that we have actually have the correct credentials to access both the Tanzu registry so we can pull the container images for tap, and we have access to the workload registry where we're going to publish our container images. And this is simply going to use a Docker login using the credentials we put in the settings.sh file. Looks like I have the right credentials. The next step is we're going to actually install something that's called Tanzu Cluster Essentials. And with Tanzu Cluster Essentials, what we need to do is we install two controllers. One is called the cap controller. This is what's used by to install all the packages. And we also need to install something called secret gen controller. So this script is going to take care of installing those controllers for you on the cluster. So you can see here, if we do k get ns, we now have a few extra namespaces like cap controller and secret gen controller and a couple other bookkeeping namespaces that are used. Now that we have that installed and it's working, our next step is to create what's called the tap install namespace. And we can do that by running the script number 3, which is the configure tap install namespace.sh. What the script will do is it will create the namespace called tap install. That's what you see up here. It will then add a secret called tap registry. This secret has the credentials to access TanzuNet, so we can get the container images that are part of tap itself. And then it's going to create another secret called workload registry, which is what we're going to use to publish our workloads to tap. Now, it will also create, in addition to that, a what's called a package repository. The package repository is pointing at TanzuNet, and this package repository is going to give us access to all of the packages that are make up Tanzu application platform itself. So once that's reconciled, that means that we are ready to run the next step, which is the install step. So there we're going to do 04 install tap. Now this step is going to begin the process of installing all the packages that are part of tap. And we can monitor its progress by going to a different window, and we can run the, if we look at our scripts here, you'll notice that we have a script called debug watch package installs. So let's actually run that script, number 20. And what the script will do is it's running kubectl get pkgi, that's short for package install requests, from the tap install namespace. So what you're going to see here over on the screen is that various packages that are part of tap are in the process of being installed. You'll notice that they have two states, reconciling and reconcile succeeded. When it's reconciling, that means it's still in the process of installing it. When it says reconcile succeeded, it means that it's actually managed to install all of the Kubernetes objects that are part of that container package. So this is going to take a few minutes. If you are, when you install this for the first time, one of the things that has to happen is it has to download quite a few images. So if I go do something like Docker images on my machine here, you'll see that I have quite a lot of images, and some of them are pretty large. And so the first time you run this, it's going to take a little bit of time to complete. All right, now, if you've made mistakes in your settings.sh file, you might find that some of these might say reconciliation error. So in that case, you have to do some troubleshooting. And I've provided you with a set of scripts to help you with that. So if we look here again in here, you'll see that we have a script called debug dump package bundles.sh. When you run the script, it will do the following. It will create a directory called packages underneath your workspace folder. And in this packages folder, it's going to go through and download all of the YAML of the packages that you're installing. So for example, if we take something like Contour, okay, you'll notice here, this is a standard Carvel package. If you're new to Carvel, check out carvel.dev, the website. Here we're going to find all of the resources that are involved in installing this. What I find is if I get an error message, sometimes it's helpful to review the YAML that's being installed by the package, and that can give me a hint as to what I may have done wrong. So look at that. It looks like it has succeeded. At least that's what it's telling me here. And if I go over to my, over here, you can see that it looks like everything is reconciling. So let's do get pkgi, and boom. Okay, now this package here that you can see, tap17.2, that package, when we installed it, it caused all the other packages to be installed. So at this point, I can go and I can say get http proxies. All right, let's just search for all HTTP proxies created by Contour. And you'll notice that one of those proxies is set to tap-gui.tap.local.tanzu.ca. All right, let's see if we can take this URL and visit it. Oh no, it errored out. Well, why did it error out? Well, it errored out because normally in a default installation of Tanzu application platform, we would be creating a Kubernetes load balancer for this. However, when you're running on your laptop with something like Docker Desktop or Minikube, load balancers tend to be quite problematic. So what I've done is I've actually configured it. Well, you can see this here under, is I've requested the Contour be installed with a node port. And because it's going to be installed with a node port, so let's do get all-n Tanzu system ingress. As you can see, Envoy, which is part of, which is the data plane for Contour, is currently deployed on 2 node ports, 32695 and 3396. So in order for us to get traffic on 127.0.0.1 on port 80 or on port 443, we need to map the two. And this is precisely what we do with the script number 5. So if we take a look at it, you'll notice that this script, proxy traffic, is going to run the command with socat. Socat is a utility that basically is going to take all of the TCP traffic coming on port 80 and is going to send it to another port. Now, which port is it going to send it to? Well, we'd like to send it to the ports, to these ports here, because that's where our ingress controller is listening on through the magic of Docker desktops built in Kubernetes. So the way the script works is we use a kubectl command to figure out what is the node port for the HTTP service and what is the node port for the HTTPS service, and we map them. So all I have to do now is just go 05 proxy traffic.sh. Because it is listening on a low port number, I actually have to type in my password. Now that I've got that going, let's go here and let's refresh the page. Aha! So at least now we didn't get a can't connect, we get a warning. And the warning is that our certificate is considered to be not secure. This is true because we're using a self-signed certificate. So what we're going to do is click on advanced, and we're going to accept the risk and continue. This will take us to the login page for Tanzu application platform. And because we've configured GitHub as our authentication provider, we're being asked to log in. So I'm going to click on sign in. Okay, and that's going to pop up the single sign-on window. I'm going to say continue. Ta-da! We are inside of a fully functioning Tanzu application platform running directly on your laptop. So when I click here, I can see all the standard components of Backstage, including the supply chain. All right, well, there you go. That's all it took for us to install Tanzu application platform. But let's actually go a step further. What I'd like to do next is, what you'll notice here is that there are more things that we can install. So one of the things I'd like to install next is Spring Cloud Gateway. And there is a little helper utility here file to install that. So I need to go and I need to run 06 install Spring Cloud Gateway. This is going to, again, use the Carvel package management capabilities within the Tanzu CLI to actually do the installation. Right. Now, this is optional. Now, if you don't care about Spring Cloud Gateway, don't need it, don't run this script. Right. There's also a component called the application configuration service that I'd like to run. And that is in 07. So we're going to do 07. We'll get that installed. So that's going to give me a whole bunch of extra goodness if I'm a Spring developer. Now, with these, while that's installing, the next thing we're going to do is we're going to actually deploy a workload and check that it gets containerized and it works. So what you'll find here is that there's a directory called dev, and in the dev folder, there's a namespace. Now this namespace has a special label on it. That label is called apps.tanzu.vmware.com/tapns. And the presence of this label triggers something called the namespace provisioner, which is a component of tap. And this namespace provisioner allows us to configures a whole bunch of prerequisites for you to then deploy a workload. So we're going to do kapply-f namespace.yaml. That's going to give us the namespace. We also have here a workload YAML that you can use. Now, workload YAML is kind of like one of the key features of Tanzu application platform. It's the shortened way that you deploy a workload. You'll notice in here that there is an operation. there's some kind of hints for you for what you can do. So you're going to just copy this command and paste it down here and say yes. And once that gets created, we can actually see what it's doing by looking at the logs and tailing the logs. All right, so let's make this a little bit bigger here. So this is going to go through the process now of invoking the Tanzu build packs and the Tanzu build service in order to containerize our code. Now, the first time you run it, it's gotta do a bunch of stuff to warm up. So it's going to take a little bit of time. So while this is running here, I'm going to go back to the GUI here. And I want you to notice that now we have this thing here called a supply chain. And in the supply chain, we see that there's a Tanzu Java web app. And this diagram here is going to show the progress, a visual representation of the progress of our workload through all the stages it needs to go through in order to eventually run on the cluster. Okay, so for now we're just going to wait for it. All right, so it is kind of in the process. You can start seeing the build packs are starting to get going and run. So while it's running, maybe one interesting thing we can look at is we can take a look at the Docker desktop. So we go here to settings, and you can click on the little icon there. And this will give us a view of how much resources we're using right now. So as you can see, my installation of Tanzu Application Platform is using 6.23 gigabytes. That's what the containers themselves are using. In this particular instance, I have my Docker desktop configured with a maximum of 24 gigs. And there are 12 cores on my machine. So it's currently using only 12.57% of them. All right, it looks like our build is successful. Let's go up here and check in on the supply chain. We can see that the supply chain has gone through source code to producing a container image, to figuring out the YAML of the generated image, like what to do to deploy. And it's now in the process of actually deploying it to the cluster itself. That's kind of what the last step is. So while that's happening, let's go over here and learn how we can see where our workload is located. So when you click on home, you're going to be on the software catalog. You'll notice there's some pre-registered entities, but the app I just deployed, it's not there. So I need to click on register entity, and I'm going to go over here, back over here. I think I've left a link in the README file for this. So when we go down to the instructions, it should say that we can take this URL over here and use that. So I'll copy that, I'll paste it over here, click Analyze, Import, View Component, and now this is Tanzu Java Web App is in our system. If we click on Runtime Resources, we're going to see all of the Kubernetes objects that correspond to this application. We are interested in the Knative service, so we'll select that. And that'll show us, yes, there is a Knative service. So let's click and look at that. There's a URL. So I can just click on that. Again, because we're using a self-signed certificate, we have to go through the process of accepting the risk. And ta-da, there is my application. It's up and running. Now, there are other features here that are important to know about just to prove to you that it's all working. So if I scroll down, I can click on the pod. And look at that, I get App Live View. I can actually see what my Spring application is up to through its actuators. So in summary, what we did is we started with an empty Docker desktop Kubernetes. And then we went through and ran a series of scripts, which got us a fully functioning Tanzu application platform. What we had to do to get going was copy the settings templates file into settings.sh, provide it with a bunch of values, and then go through and run these scripts in sequence. I showed you a lot about how these scripts do their business. And then if you click on the README file, everything I did is spelled out in here step by step. So if that's all you needed to see how to run it, you're all done now. You can just stop the video. However, if you'd like to dig a little bit more with me into how does this actually work, we can go through some of the scripts right now. So our validate script is not very interesting. It's just standard bash for checking if certain CLIs are present or not. So we're going to skip it. Our login script is just doing docker login with the provided values from settings.sh. In the install cluster essentials, gets a little bit more interesting. What we do is we first make sure that the workspace directory exists, and then we perform what's called an image package pull using this particular file over here, which is passed in via environment variable. And that will download into the workspace folder the cluster essentials, which is a set of packages, Carvel packages that are in here. And our goal now is to install these packages. And we would like to install them into the Tanzu cluster essentials namespace. So that's why we start by creating a namespace called Tanzu cluster essentials. Once we've done that, we need to invoke YTT, which is one of the tools in Carvel. Now YTT, when it runs over our to install cap controller, is going to need to know the credentials to use to pull the container image. And so what we're going to do here is we're going to take our existing TanzuNet creds and we're going to add them to an environment variable, set of environment variables that start with YTT underscore, because that's how you can pass values into a YTT invocation. And so what we do is we make sure there's a directory called generated underneath here, and we then invoke YTT. We pass it the various directories that we want it to process, and then we tell it to output a file. And the file that's outputted is called capcontroller.yaml. It's right there. Now this file is not quite ready to be deployed to our cluster, because what we want to do is make sure that any kind of tags on container images are replaced by actual SHA-256s. So for that, we run this tool called Kbuild, which is another tool that's part of Carvel. It's going to search through our YAML file that I just showed you, this one over here, and it's going to output a new file called capcontroller.resolve.yaml, because that's what I kind of called it up here. And then that file is going to have SHA-256s for all the tags. So if I go here and I search for image colon, right, you can see here, for example, that I have an image and it's actually pointing to the SHA-256 and not to a tag. This is what you need in order for it to be a very stable installation. Also, we allow you to do an installation in air-gapped environments or in environments where you just want to use your own container registry. So you can easily move your container images from the Tanzu container registry to your own corporate one. So let's close that out and continue on with our install cluster essentials. So we do, like I said, we generate the YTT, we use YTT to generate the file. Then we make sure that it's got the right image tags, and then we just use the cap CLI, which is another tool from Carvel, to deploy this. Then once that's deployed, we repeat the same process to deploy the secret gen controller. Secret gen controller is responsible for replicating secrets between namespaces and various other things that are makes life easier for platform engineering on Kubernetes. So once Cluster Essentials is up and running, then what we do next is we can configure the top installation. So what we do is, you can see, we start by creating the top install namespace, and then we create a secret to access the Tanzu registry and a secret to access the workload registry where we're going to publish our containers. Then we add a Tanzu package repository and get its status, because we want to see that it's reconciled. Then when it comes to installing tap, that's pretty easy too. Same story again. Now what I'm doing here is I always start by reading the settings file.sh in these scripts. You probably noticed that already. But I apply this secret here called contour overlay.yaml. Let's actually take a look at this. So one of the things that, one of the assumptions that tap makes in the default configuration is that you have more than one worker node. And so contour is going to deploy for high availability, it's going to deploy the contour controller with two replicas. This is just a personal installation on a laptop. I don't really need two replicas, so I bumped that down to one just to save a little bit of memory and CPU. But more importantly, you'll notice that there's an Envoy deployment, and that Envoy deployment has a default replica count of 2, but it also has anti-affinity rules that say that the pods cannot be on the same worker node. Because you're running Kubernetes, Docker Desktop Kubernetes, there's only one worker node. And so it'll never reconcile if we keep it with the default settings. So what I'm doing here is I'm basically reducing the number of Envoy instances, replicas, down to 1 so that it would actually reconcile. So that is all there is in tap. So we do that. So in order for overlays to work, we need to put them in a secret. And this secret is actually referenced directly in the tap values template, which you see over here. You can see it says, hey, package overlays. Hey, Tanzu, when you're installing, please make sure you do some customization of the contour package during install time. So let's go back to the install. So we go through a process of we basically want to take some of the settings in our environment variables and make them available to YTT. That's why we're kind of collecting them in a set of environment variables starting with tap underscore. And then we generate our tap values file based on our input. So again, if you look in the workspace generated, you'll see the tap values.yaml file down there. That is what's actually going to be used. And then we do Tanzu package install tap. We pass in the name of the package we want to install, the version, where our values configuration file is, and what namespace to put it in. And that's what usually takes 5 to 15 minutes on Docker Desktop to just get you up and running. And that's all there is to that. Next is the proxy traffic. This is using SOCAT. And there's really not much to it other than it just moves proxy's traffic from port 80 to whatever is the node port. And I believe I showed you that earlier in the video. Installing Spring Cloud Gateway, again, very simple process. The Spring Cloud Gateway is part of the Tanzu package repository, the tap package repository that we added, but it's not installed by default. So what I do is I run this command here to extract the actual version of the package that's available. And then I just call Tanzu package install Spring Cloud Gateway, and life is good. It installs. The next thing I do is for installing the application version, like the application configuration service. It's very similar to what you saw for Spring Cloud Gateway. First, we figure out its version, then we install it. However, there's one extra argument here, which is that YTT overlay file. So one of the things that the application configuration service does, it needs to connect to the API server, and it needs to get certain information from it. Unfortunately, it seems like that initialization process is fairly slow on Docker Desktop. And so what I've done here is I've went and I've tuned the resources of this particular deployment, and by removing CPU limits and setting memory to a lower amount, 768 megs. And I also increased the initial delay for the liveness probe, the readiness probe, and the startup probe. This way, if the application configuration service is taking a little bit of time to launch and connect to the API server, it won't end up like shooting it in the head and then trying again, which is very unfortunate when you just need a little bit more time to finish the job. So putting this at 30 seconds gives it that time. So that explains the that particular one. So we've covered all of the install stuffs. This is pretty simple here. The debug one, watch get pkgi tap install, just easier than just typing it all the time. This particular script is, when you do kubectl get all, you don't really get everything. You just get like a few object types. This really does print out everything on your cluster. If I go here and I do something like .21, it's going to really dump everything. Fantastic. That's going to take it a while because there's a lot of objects now in the cluster. Dump packages just goes through and queries existing packages via kubectl and spits out all that information into the workspace packages folder, which I showed you earlier. Cartographer, this is going to dump all of the supply chain objects. That's a bit of an advanced topic, but I'll skip over it. So I'll skip over it. The last thing is there is a script here that if you want to delete everything, you can. This will go through and delete things in reverse order. It'll start by killing off any namespaces that are marked with the namespace provisioner, and then it'll delete them in reverse order from what it did. Right? So be careful if you use crossplane and you create a bunch of objects. I've explicitly told it in the configuration that I do not want it to orphan I don't want it to orphan crossplane resources. So there's a bit of a warning and a link here. Check it out if you don't understand what I'm talking about. Pretty much for local Docker desktop deployment, you want this all the time. But if this was production, maybe not. Okay, so that's pretty much it. Thank you so much for your time. I really appreciate it. I hope you found this educational.